Okay, so we missed 18, 19, and 20 from the grid last video, so we're just going to do them now. So for this question, they said find the value of f of minus 2, but we can't do that because a and b are unknowns. We have to find them. So since it is continuous, that means that the left limit is equal to the right limit. So a so the left limit equals right limit, so minus 2 minus 1 plus 1. So this becomes minus a minus b plus 11 equals 3. So a plus b equals 11 minus 3, which is 8. Then we have to equate the derivatives. So the derivative is 3a x squared plus b is equal to the right derivative minus 2. And this is at x equals minus 1, so the x squared becomes minus 1 squared. So simplifies to 3a plus b equals minus 2. And then from the other one, a plus b equals 8. That ends up, when you subtract it, 2a is equal to minus 10. So 2a is equal to minus 10. So a is equal to minus 5 and b is equal to 8 minus 5, which is equal to 13. So a x cubed plus b x plus 11 is the function for f of minus 2. So you get minus 5 minus 2 cubed plus 13 plus 11, it's equal to 25, and that is the answer. Okay, so for question 19, you have a function that has a left side and a right side split at 0. So the first thing and the easiest thing to do is find out if it's continuous over there. So at 0 minus, the function is 1, but at 0 plus, the function is 0. So since it's not continuous at x equals 0, it's not differentiable at x equals 0 either. So f of x is not differentiable because f of 0 does not exist. It does exist, but since it's not continuous, it's not differentiable, so the answer is wrong. So f of x is not continuous, but is differentiable? No. All differentiable functions are continuous. And since it's not continuous in the first place, the answer is wrong. F of x is not differentiable at x equals 0 because it is not continuous at that point. Yes, that's correct. F of x is differentiable at x equals 0? No, because simply because it exists, it does not mean it's differentiable. Their derivatives have to be equal. The limit of f as h tends to 0 and f of h minus f0 over h does not exist. Yes, because that's a derivative, and the derivative doesn't exist. And that exists? No. So it's just 3 and 5. Okay, so for question 20, it's basically the same thing. So first you find out if it's continuous. So the function at 0 minus leads to 2 multiplied by 0 plus 1, which is 1. But at 0 plus, so from the left, it leads to minus 0 squared plus 1, which is 1. So it is continuous, but it doesn't mean that it's differentiable yet, so you have to check that. So you find the derivatives of each side. So 2x plus 1 derivative is 2, and then the next one derivative is minus 2x, so it is not differentiable. So then you go to the choices. So f of 0, yes, it exists because there's an equal sign here, so you circle it. The limit of f of x does not exist, but it is continuous over here, as you can see, so it does exist, so this one is wrong. The limit of as h tends to 0 of f of h minus f of 0 over h does not exist, which means it's not differentiable, as we saw over here, so this is correct. F of x is continuous at x equals 0, yes, and f of x is differentiable at x equals 0, so it's not, because the derivatives are not equal, so this is wrong. So the answer is 1, 3, and 4.